So today we're going to solve radical equations. So a radical equation is an equation that has a radical in it. Today we are going to stick strictly with square roots. So whenever you have, so here are two different equations. Whenever you have equations that have radicals in them and the variable is under the radical, you have to undo the radical in order to be able to get to this variable and to be able to isolate it. So we have a couple different types. You have ones where you have a single radical in an equation and maybe a number on the other side. So what you want to do first is to make sure that you isolate the radical. So you want that to be the only thing on one side of your equation. Once that's isolated, then you're basically going to undo the radical. So we all know that this is a square root. So the inverse of that is raising it to the power of 2. So if you raise something that's a square root to the second power, then the power of 2 is going to cancel that square root off, and you're left with just whatever that radicand was. But we all know with equations, what you do to one side, you have to make sure you do to the other. So if we're going to square the left, we have to square the right. And 6 squared is going to give us 36. And then once you do that, you're down to a pretty basic equation here. All you have to do is get x by itself, subtract your 10, so we get x equals 26. Okay, whenever you're solving radical equations, they always put in the directions to make sure you check for extraneous solutions. So what that means is sometimes when you square both sides of an equation, if this side over here has a variable with it, then that might create an answer that doesn't necessarily work. So you can just do a quick check here. If you put 26 back in, 26 plus 10 is 36. Square root of 36 is 6, which gives us a true statement. Okay, whenever you see that in the directions, it's not really going to apply to these ones whenever you're squaring a number, but if you end up squaring a variable, which we're going to do here in a couple minutes, that's when those extraneous solutions will come into play. All right, so here's another example. You want to make sure you isolate your radical first. That has to be the first thing you do. Isolate your radical. It's going to make everything much easier. So you see how we have this 10 out front? We want to divide both sides by 10 first. So 40 divided by 10 is just 4. Our 10s cancel out. Now we have the square root of 8a. So now we're ready to just go ahead and square both sides. If you square this side and this side, then your power of 2, that cancels off that square root. 4 to the second power is 16. And now this 8a is no longer under a radical. It's just out. It's free. And then we divide both sides by 8 because the ultimate goal is to get the variable alone. So a equals 2. Okay, our next example here, this one, we have a square root equal to a square root and nothing else around the square roots. We don't have any numbers out in front or anything. So this one, square both sides. Square this side, square this side. So what that does is it just makes the square roots just completely go away. So we're just down to an equation where we end up setting the radicands equal to each other. Okay, so now all we're going to do, isolate your variable. So I'm going to start by adding m to both sides. Because I can cancel those off. And then I'm going to add 5 to both sides. You guys know you can really do this in any order that you want to start with. I just like my variables on the left. Okay, so I'm left with negative m equals 7. And then, of course, we're not done until this guy's positive. So we're going to divide both sides by negative 1. That was. So then we get m equals negative 7. All right, and then our last example here, we have one radical set equal to a variable. So just like when it's set equal to a number, you want to make sure that the radicals all alone. So this one it is, which is good. So now we're going to square both sides. So if I square this side, I have to square this side. Now this is where the extraneous solutions are going to come into play. So an extraneous solution is like an answer that you get by solving the problem and you did everything correctly. However, when you go to plug it back in, it doesn't actually work. So that happens because what we're doing by raising this to the second power, it's like we're throwing an extra variable into our equation, which that wasn't there in the first place. So if you square both sides, then these are going to cancel off, and then we end up with 6 minus r equals r squared. Okay, and then hopefully you recognize this. This now is a quadratic. So we have an r to the second power, an r to the first power, and then a constant. So you're going to have to solve it by factoring. So set it equal to 0 first. So you're going to set it equal to 0, and then you're going to have to factor it. Okay, so setting it equal to 0, I'm going to actually bring these guys over here because I like when my quadratic term is positive because it makes the factoring much easier. So you can add r, so you would bring r over to the other side, subtract 6 to the other side. So we'd end up with r squared plus r minus 6 equals 0. Okay, because let me just put that, the steps in there. You would have to subtract this 6, and you would have to add this r. So if I subtract 6 and add r, these cancel, and then this is what I'm left with, but then you want to make sure you put it in standard form. Okay, so now we're down to factoring. You need to look for two numbers that multiply to -6, but add to +1. So those are going to be r plus 3 and r minus 2. Solve by factoring. So we got to keep going until it's r equals. So set these guys equal to 0. So for this one, r equals -3, and for this one, r equals +2. Okay, so we need to check and make sure these are going to work. So if you plug your -3 in, you would end up with, let's check this one. So the square root of 6 minus -3 equals r, which is -3. Okay, so if I do 6 minus -3, this gives me 6 plus 3, which is 9. If I take the square root of 9, I get 3. 3 equal -3. Well, that doesn't make sense, right? So +3 doesn't equal -3. So those are not true. So that means this one was my extraneous solution. You have to check. So if I want to check my 2, then what I'm going to do is I'm going to do the square root of 6 minus 2 equals r, which is 2. 6 minus 2 is 4, so I have the square root of 4 equals 2. The square root of 4 is 2, and see, that's a true statement. So that one works. So this is your answer. This one doesn't work. Okay, so that always happens whenever you end up squaring a variable when you're solving these. When you square both sides, and it was a radical equal a radical, you won't have to worry about extraneous solutions. When it's a radical and a number, you won't have to worry about extraneous solutions. But anytime you square a variable, this is when it's going to happen. So just make sure you go back and check. All right, I'm attaching a practice worksheet, so please email me if you have questions. Thanks, guys.